Presentation divided into these three parts. I'm going to emphasize how to do the wiring. On this slide, I'm going to introduce how to do the modularization. And for example, in this tie, you just have two chillers, chiller number 1 and chiller number 2. And for the modularization for the inverter, and you need to connect the CN25 to this CN33, just like this. And also from this CN25, you can connect it to the controller, which is here. And actually for the inverter, the controller is just like this, and it cannot modularize with the on-off series. And actually from here, there are just two ports. CN4 is for the connected to the chiller, and this is the outdoor unit, the control main board. And here is the controller socket, which is this CN25 and CN33. And besides, you also need to change this switch, which is located here. Generally, if this chiller connected to the controller, this one is the master, which means that this switch should be all to bit 0, just like this. And for this one, you just need to change to different, it's okay. And if you're going to connect to more than 2 chillers, this connect from this CN33 to next CN25. The maximum we can connect it up to 16 chillers. And just like what I said, from this CN2, it's output the RS485 signal, and from this RS485 converter, you can connect to BMS system. And actually for this one, you can buy gift from our grid, so we can offer you these two according to the different output. You can also buy it from your local market, which means for this one, you don't need to buy it from our grid. And once you require, we will provide you this RS485 protocol, so you can control the chiller, which is this one, from the computer. And this is for the inverter series for the modularization. It's for the on-off, which is the D or E series. The wiring is similar, and but this one, the controller is different, which means you can also identify from the model. It will be CS15A. But also from here, there are two ports. CN5 is to connect it to the chiller, and CN4 is output the RS485 signal for the BNS control. And also for the on-off, we have another controller, which is this one, CF61. And for this one, and the wiring is also similar, which means from the first 25 to the next 33. And also need to change this switch. And from here, is also need to connect it to the BNS system. But before that, for this CF61, we need a ME30, which is this one, as we need to change the output to the RS485 signal. And from here, you can also find that there are actually 3 ports. One is to connect to this CF61, the other is to combine them together. And here is going to introduce if you would like to combine the on-off and the inverter chiller together. Here is how to do it. So for example, this one is the on-off, and also this one is the same, and this is the inverter series, which means also you can identify from the controller, right? And you need to use this CF614 for the combination. You can find it. We just output the signal, which is from here, and combine them together, and then from this RS485 converter to connect to the computer. And if the communication length is more than 800 meters or more than 30 modules, which is more than modules of this one, you need to use this repeater to ensure the communication. And this is how we do in China domestic market, which means from here you can also find that for all the chillers, including the modular chiller or the screw and the centrifugal chiller, we always have a GPRS or the 4G. Then we can transist the operating data to the base, and then transist it to our grid cloud. So with computer or the smartphone, we can access it and get the operating data from it. And this is for China domestic market. And for the overseas market, and for this part, especially for we don't have an 4G or GPRS signal to transist the data, so you can use the Ethernet cable to transist the operating data to the local server, and then we can use the computer or your smartphone to access it to get the operating data. And of course, this requires the engineering customized. For the next chapter, I'm going to introduce the refrigerant cycle and the water cycle. And first, I'm going to introduce how the refrigerant cycle and water cycle flow in cooling mode. And on the left side is the refrigerant cycle. Right side is the water. They just combine together with this tube and shoe heat exchanger. And on the refrigerant cycle, we have the compressor, four-way valve, auto heat exchanger, EXV, and also the gas liquid separator. And also on the refrigerant cycle, we have lots of the switch or the pressure sensor and temperature sensor to check the system, and also to maintain the operation can be within the desired range. And here is the refrigerant cycle. Coming out from the compressor, the hot and temperature and high pressure gas will flow to the auto heat exchanger to release heat. Then the gas will become liquid and get expanded at this EXV. And then from here, it will be the low temperature and pressure liquid, and go to this one to absorb heat, which is doing cooling to cool down the water. So the refrigerant itself will become gas and flow back to the gas liquid separator. After separated the liquid part, the 100% liquid will flow back to the compressor. And this is for the on-off series. As for the inverter series, we need to change here, which is at the IPN module. And this one, the purpose of this is just to cool down the compressor dry, as the compressor dry will just will release lots of the heat. We need to cool it down and with the refrigerant. And also add another EXV. This two EXV here is just to ensure the refrigerant which is gets through the IPN module, not to so cold. So, and this is the refrigerant cycle. Just focus on the water cycle. On the water cycle is regular. We have the expansion tank and water pump, and also before and after this tube and shoe heat exchanger, we need to use the temperature and pressure gauge to check the temperature and the pressure. And also this is the FCU, just for example. So the water just coming out from the water pump, it will flow to this one to being cooled down, and coming out will be the chill water, right? And this chill water will go to the FCU to absorb heat, which is ensure the temperature not to go so high, and then coming out will be the water, and then flow back to the water pump. And this time it is the heating cycle, and the structure, which is the chiller and also the water system, is no change. And what's different is we just change the direction on the four-way valve here. And here is how the refrigerant flow. The gas from the compressor will first flow to this to ensure heat exchanger to release heat, which is to heating up the water. Then the refrigerant itself will become liquid and flow to this EXV and get expanded. Then the refrigerant become low pressure and temperature liquid, can go to auto heat exchanger to absorb heat. Then itself will become gas and flow to the gas liquid separator, then to the compressor. And also focus on this refrigerant cycle. This is for the on-off, how we control it. And for the inverter, and if you have remember well, just at last slide, we just had the IPM module here, right? And which is this one. And this time, the refrigerant will get expanded at this ESV2. This is for heating. ESV1 is for cooling. The purpose of we set to ESV here is just to ensure the refrigerant gets through this IPM module. The temperature will not be that cool. If it's very cold, it will just make the condensing water, and then the condensing water will absolutely damage this IPM module, which is we need to avoid. So, and this is all for the refrigerant cycle. As for the water cycle, this time is no change, which means we don't change the direction, and also the water from the water pump will flow to the heat exchanger. After heating up, will become the warm or the hot water. Then we can make this hot water to flow to the FCU to release heat, which is doing heating. Then this water will be cooled down and flow back to the water pump. For the next part is the detailed troubleshooting. First of all, what is error? And actually in the chiller system, we always monitor every important parameter like the compressor discharge temperature and the pressure, and also the outdoor temperature. And for this one, we always we adjust the components setting like the compressor or the outdoor fan RPM and even the ESV opening to keep above, which is the our important parameter. We make sure it is in the desired range. And just like this, for example, we have for every important parameter, we already set up the regular control zone and also the protected control zone. And for example, we take the compressor discharge temperature, for example, and if it is higher into this protected zone, we will adjust the parameter like to decrease the compressor RPM or to higher the EXV opening to make it to going down. And next time, if it is lower than the regular lower limit, we adjust the parameter to make it to be higher. And once it is in this zone, the system will not do any protected control to do that. But if it out of this protected zone, the system will have no idea but just shut down and display the error code, which is E4. As for how to check the operating parameter, for the on-off, which is the D or E series, which use this CF15A controller, just press here to check and then select which out unit, which is the which chiller, and then select the item, either the temperature or the component status. So here the status will display the status of the components, and here is the temperature. As for the inverter series, which use this controller, press here and select which chiller, then select the data or the status. We will also play this one for you. And this is all the information we will provide you from the controller, including the components status, on, off, and all the solenoid valve. As for the parameter, once we have in our temperature sensor or the pressure sensor, we will always display this for you. This is the maintenance tools you may use during the troubleshooting. And this is the multimeter. And this is the grid tie ammeter to check the current. And this is the refrigerant leakage detector. And this is the pressure gauge to check the refrigerant system pressure. And also you need to equip with this spanner and screwdriver. And this isolation tester is to check the compressor resistance. Later I will introduce how to use it. First is the temperature sensor. We also call it thermistor. Actually, the temperature sensor, it is just a resistance, but it is the value is very sensitive to the temperature, which means if the temperature change also leads to the resistance value change. Then for the PCB, we always use the voltage to check it, which means the voltage also change. Then the PCB can get the temperature information. And based on that, the system will change the component parameter. And inside the chiller, there are 3 types of the sensors, which is the 15K ohm. It is for the high temperature, which is the compressor discharge pi, and the 50K ohm. It is for the low temperature, which means the outdoor ambient temperature. And the last is the 20K ohm to check the tube and also the water. And also you can find it. This is the relation between the resistance value and the temperature sensor. And also you can find it. We always use this part to check the resistance and also the temperature, which means it is more sensitive, right? So this is the reason why we need to have 3 types of the sensors, because the sensitivity is different. And why we call it 15K ohm or the 20K ohm is based on when the temperature is 25 degrees and the detected resistance value, if it is 15, just like this is the 15K ohm sensor. And how the system will use this information is just like this. And for example, the compressor discharge sensor, and we know that the compressor should not be overheat. If it become for example 130 degrees, it will lead to the oil decompose, which will shorten the compressor lifespan. So on the system, we always put this temperature sensor at where it is hottest, which is the compressor discharge, and always keep it watch. and also set in the control program if the detected temperature is higher than, for example, 102 degrees, we just increase the EXV opening to make the refrigerant to flow back to the compressor to cool it down. And the next is if higher than 112, we have no idea, but just reduce the compressor RPM. And if it is higher than 120, this time we have to shut down the system for protection. And first is I will introduce how the system will judge or display this temperature sensor error. Actually, the system always gets the AD value from the sensor. If this value exceeds the upper or lower limit for 30 seconds, for example, it will display this error. So you can also double check from the display here. And the checking method is first to reconnect the sensor to this connector, and then to check the resistance value. Just compare with the standard resistance value whether it is okay or not. And here is how we do in China. And in China, when we do the troubleshooting, we always bring a good temperature sensor and just compare the good one, the resistance value, with the suspicious one. If these two values not change too much, that means the suspicious one is okay. And after that, something wrong with the main board, you need to replace it. Next is the freezing protection, which is the temperature for the cooling. As you know that for the cooling, if we make it too cold, as it just make heat exchange with the water. For the water, the most problem is it will be frozen, which is become ice. And then from this picture, you can also find that if it become ice, it will just damage the inside components, which is the to ensure heat exchanger. You can see that from this picture, the frozen we just make it to be bent, and also from this is we make it crack. And here is how to make the system will display this error. Why? And from water side, we just detect the water temperature at the living water and also the anti-freezing. We check this one if it is lower than the setting value, and we trigger this error. And of course, if this error higher than the preset malfunction frequency, like 1 hour, 3 or 4 times, we will log out the system from restart. And before that, we also had the freezing protection, which is if we detect the temperature is lower than the setting value plus the preset value. For example, 3, where we just lower the compressor RPM. This is for the inverter, and for the for on-off series, and we only have this one, which is if we detect it lower than this, we need to shut down the corresponding chiller and first turn off the compressor and then turn off the fans. And automatically recover if we detect the AD value, resume to the desired range. And of course, we recommend to reset the power. And the next is the high pressure sensor error. This time is just the sensor itself, not the system detected AD value, and which means according to the pressure AD value, we get it from the sensor. The PCB always will change the parameter, just like change the compressor RPM or the fan RPM and even the ESV opening to maintain the system reliability. And maybe this pressure sensor is open circuit or short circuit, leads to the AD value exceeds the limit. And the action is just like this, and the system will shut down the corresponding complexers, and after shutdown we will shut off the fans, but also maintain the water pump operating. And if it is in heating, the four-way valve just will make the position. And of course, if this this AD value resume to the desired range, it can recover. And of course, if this error, the frequency is higher than our setting, the system will log out from restart. And for this feature is the same to all our errors. And here is how to check it. And of course, first is to check this connection, to reconnect this connector to the main board. And on our system, we also have lots of this port. So you can use the pressure gauge to check whether the pressure is really so high or not. And the last one is just something wrong with this PCB. You need to replace it. And the next is the complexer or the complexer drive malfunction, including the complexer overcurrent, complexer IPM malfunction, or the desynchronize of the complexer, and the complexer startup failure. And actually, this is has the relationship with the current, especially the complexer current is higher than our preset value. It will trigger this error. And here is the actions. Actually, first to shut down the complexer, and if all the complexer with the same chiller is shut down, then we can turn off the fans of this chiller. And also at the same time maintain the water pump operating. If in heating mode, we will make the four-way valve position. And of course, this will automatically recover if the detected current is less than our preset value. And here is how to do the troubleshooting for a completely new system. This time you just need to check whether the power supply, especially the voltage, is really too high or not. And the next is to check whether the ventilation is not that good. Maybe something wrong, or some foreign objects just block the ventilation. Just consider the condensing side. And for an existing system, this time, especially for you just repair the chiller, this time you need to check whether this is the poor contact of the compressor UVW wire. And of course, to check the sequence of the UVW. After that, we divided the reason into the compressor malfunction or the dry bulb, which is the IPN malfunction. And for the compressor malfunction, and we're just afraid that maybe the inside coil, just like this picture, it will just burn, and also leads to the inside open. This is the wire, for example, this is the UVW. This wire is open circuit or short circuit. So we just need to check the resistance value of this coil. So use the multimeter and change it to the ohm. And then measure the U to V, U to W, V to W, which is these three coils. The value, it should be less than 2 ohm. And also the next is to check the isolation resistance of each terminal, which is each terminal with the earth. And this value should be more than 10 mega ohm. And if during the operation, if you heard the abnormal noise, also you can judge something wrong with it. I will display 2 audios for you, and you can judge that which is abnormal. First is this one. And the next one, and please attention to the loud noise. So you can find that it's completely different, right? And the reason is the number 2, which is the last one, is a malfunction. So you can judge that from the noise. And next is judged from the temperature rise, which is during any time. You just find that the compressor temperature in anywhere, if it is more than 120 degrees, you can also judge that the compressor is malfunction. This is the procedure when you're going to replace the compressor. Just follow this one. To replace it is okay. And the first one is to judge whether the oil quality is contaminated or not. And how to judge it is just like this. And from the color, from the transparency, from the viscosity, and the smell, you can judge it whether it is clear or contaminated. Back to here, if you find that the oil is not clear, you need to clean the pipeline and also the inside components. It is really a tough job. And after that, it's the same as when the oil is clear, disconnect the power supply and clear the electrical part and remove the compressor. And you can also find that whether the oil is contaminated or not. We still recommend to change the gas liquid separator. And after that is change the compressor and do the system leakage check and charge the refrigerant, and also to connect back the electrical parts. The reason why we require this one is this. And this is the sectional view of this gas liquid separator. The refrigerant flow in from here, and the liquid part will accumulate it here, and the gas part will flow in from this one and then to the compressor. And also you can find that there is a hole here with the filter. It is actually for the oil return, which means what we're afraid is this we're going to replace the compressor. That means the compressor is probably burned down, right? And it will generate lots of the impurities. And we're just afraid that the impurities will just blockage this filter, and sooner or later the oil will always accumulate at this gas liquid separator, will lead to not enough oil for the compressor operation, and sooner or later the compressor will run out of oil and leads to another breakdown again. And this is the reason why we require to replace the gas liquid separator. And then the next is the outdoor fan motor error. And also the fan motor is similar to the compressor. There's no oil return system. And so the judgment and also the error is very similar, including the fan motor overcurrent, fan motor IPN, and also the desynchronizing and the start-up failure. And which is when we detected the fan motor RPN is not the same as our order, especially at a start-up period. We will also trigger this error. And here is the action procedure, which is to shut down the corresponding chiller, first compressor, then the fan, and also maintain the water pump operating. And in heating mode, keep the four-way valve position. And of course it can automatically recover. And here is the checking measure. And first is to reconnect the wiring from the fan motor to the fan motor drive. And the next is just replace the fan motor. It is not that complicated. Just compare with the compressor. And the last one is maybe something wrong with this this fan motor drive, so just replace it. Next type is the high pressure protection, and this is from the high pressure switch, which means the detected pressure is higher than the preset value, about 4.2 megapascal. We will conduct the switch to open circuit. Then when the system receives this signal, we will do the actions. First is to shut down the compressor, and if all the compressor inside the same chiller is turned off, we will turn off the fans in this chiller. And then as for the water pump and the four-way valve is the same as the other errors. And of course, this can automatically recover if the detected pressure is less than this value, 3.6 megapascal. Or you can manually clear from the controller. And of course, we recommend to reset the power for this issue. So, and the possible reason I divided into these three, which is whether the detected pressure is really so high or not. And maybe this pressure sensor is a malfunction. And and after that, we can consider the reason into the refrigerant cycle. This is within the compressor start up in 15 minutes. You can focus on this refrigerant cycle, and which is why so much refrigerant accumulated at the condensing side. And after 15 minutes, just focus on the water cycle. Why not insufficient capacity, like the water flow rate or the temperature is not that good at condensing side. And here is, and this is the cooling cycle, for example. And on the left side is the refrigerant, right side is the water cycle. And within 15 minutes, check this refrigerant cycle and focus on whether the high pressure, which is this one, is really so high or not, or just maybe it is a malfunction or poor connected. And next is to check whether the FCU or the chiller on the condensing side, including the heat exchanger, the fans, and also the tube sensor, whether it's good contact with the tube, or maybe the system abnormal, just like the EXV is a blockage or stuck. First is to check the pressure switch, this one, to check the conductive, just like this, whether it is conductive or not. And next is to check the connection on the PCB, to be connected it to ensure that the connection is okay. And then to step 3 is to check the circulation, which means the ventilation, and also the heat exchanger, whether it is dirty or not, just to ensure the ventilation is good, including the FCU and the chiller. And also as for the tube sensor, yes, we have loss of the control, which is this to the ESV control. Just make sure it is good contact, just like this, with the tube. And the next is maybe the EXV is jammed or stuck. And first is to check whether it is good contact with the PCB, just like this. And the next is to check whether the wire from the EXV, just like this, whether it is broken or this short circuit or open circuit like this. And after that, you can just reset the power of the chiller to check the EXV body, whether there's some vibration or sound, just like tak 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 tak. That means the coil can drive the inside pin to move up and down. The control is okay, that means. So for the phenomenon for this one, the detail is this. And the first is no flow. That means the inside pin of the EXV is stuck or jammed at the low pulse. And here is the detail. you can also find that the outlet of this EXV, it becomes lots of the ice, it becomes frozen. And also at this time, there's no enough refrigerant to flow back to compressor. At that time, the compressor discharge temperature also will be very high. And our countermeasure for this one is just the other one for this is maybe this time the inside pin is stuck or jammed at the high powers. At that time, we just leads to too much refrigerant flow back to the compressor, which means it will also lead to the liquid hammer. And also our countermeasure for it is use your screwdriver to knock this ESV body, and for maybe 70% you can make these impurities to go through of it. And the next is just to install the coil or just replace the EXV. And here is the sectional view of this EXV body. You can just find that the refrigerant will just get through from this here. Actually, it is very tiny, just like this. You can find it, it's very tiny. So just very little impurities, if they jam here, also will lead to the control of the ESV is not that good. And here is for the ESV coils, and you can also find that. And on this case, if there's some rust here, also will lead to the control is not that good. For this one, you just replace this one. This coil is okay. And if you just worry about the coil, you can also check the resistance value. It should be about 40 ohm when the ambient temperature is 25. You can just check the public with this A or B, or minus A or minus B. And let's go back to this slide, and after 15 minutes, just focus on the water cycle. So for the water cycle, first is to check the pressure gauge. If it just like this, which means you can see the pointer just vibrate a lot, that means too much air trapped in the water system. So you can just open this band pipe to release it. It's okay. And then to check the water pump, this purpose is to ensure it has enough water flow rate. And to check the water pump, you can touch it to feel the vibration or listen to if there is any noise. And also if the water pump there is abnormal temperature rise, also means the water pump is something wrong with it. If the system is in heating mode, and you can also check the difference of the high pressure, which is the refrigerant saturated temperature, and the water leaving temperature. The difference of these two, it should be less than 5. If higher than 5, that indicates there is too much water escape or the algae inside the tube and shield heat exchanger. And for this one, this will just higher the heat transfer resistance, which makes we need higher temperature of the refrigerant to deliver the heat to the water. And higher refrigerant temperature also means higher pressure. And the countermeasure for this one is just to clean this one, just like these pictures, to clean the scale or the algae with the mechanical or the chemical methods. And also you can check the difference of the water leaving and entering temperature. The difference should be less than 8 degrees. If higher than that, that means the water rate is not enough. And why it's not enough? So you can check the water pump, maybe it's malfunction, or maybe the water pipeline is blockage, and just focus on the filter and the soft connection. Maybe it's not that good, and especially the water pressure before and after the blockage, the pressure change a lot, or maybe the water volume is not enough. At that time, also check the water pressure. If it is less than this value, that means not enough water inside. And this is the summary of the high pressure protection. And the next is the low pressure protection, and also only triggered by the pressure switch, which means the detected low pressure is less than our preset value, so we conduct this pressure switch to be open circuit. In cooling mode, it is about 0.45 megapascal. Heating mode is about 0.1 megapascal. And this is the actions the system will do if it will receive this open circuit. And also it will be automatically recovered if the detected value is higher than this. And so just focus on the possible reasons. And also the first is to check whether the pressure is really so low or not. And of course, after that is if the compressor start up in 15 minutes, this error occurs, you need to focus on the refrigerant cycle, and which is why there's not enough refrigerant at the evaporating side. And after 15 minutes, just focus on the water cycle. Why not enough capacity? Just like the water flow rate or the water temperature is not that good. And the next is the high discharge temperature protection. Actually, this one is very similar to the last one, which is the low pressure protection, and which is the compressor cannot intake enough refrigerant. And for this one, the first is it will of course lead to the low pressure, right? And the next is there's not enough refrigerant to cool the compressor down, also leads to the compressor discharge temperature to be very high. And just like this pictures, and this insert the refrigerant from here, and then this is the compression chamber. After it will just contact with the coils, and the coil is the most hottest inside the compressor. When it goes through it just cool it down and also makes it to be very hot. So if we detected this here is higher than this about 125 degrees, it will also lead to this error. And the checking method is of course, and first to check really the temperature of the discharge compressor is so high or not. And within compressor start up 15 minutes, just focus on the refrigerant cycle. And after 15 minutes, focus on the water cycle. The detail, and this time I make it to be heating. This is the heating cycle. And to check the refrigerant cycle first, and it is all very similar to the high pressure protection, and the difference is just here. Maybe there's refrigerant leakage. Here is the detail. I just focus on the different points. And for this two, which is the low pressure protection or the high compressor discharge temperature error, first we need to check the low pressure sensor, which is this one, the conducting, and this compressor discharge sensor, also to compare with the standard value. Or if this two is okay, then to check the wiring. And as for the refrigerant leakage, you can use the refrigerant leakage detector, or the salt water, or you can check whether there's some oil spot on the refrigerant copper pipe. If there's some oil spot, that means there must be leakage. As you know that the oil and the refrigerant, they mix together. If there's some leakage, the refrigerant will coming out, and of course it will bring the oil out, and the refrigerant will become gas, but the oil, it will stay. Next, we will go to the flow switch protection, and this is only triggered by the flow switch, which is the detected water flow rate is less than the preset value. And the preset value for different model, they are different. And of course, we conduct the open circuit just like a switch. And here is the actions that we will do when we see the open circuit signal. And it is the same. So here's the possible reason. And first is maybe the flow switch is abnormal. Just check the connection and the wiring. And maybe water pump is something wrong, or the water flow rate is not enough. This time just check the inside water pressure. And maybe the water system is a blockage, like the filter, or the soft connection is not that good, or maybe there's too much air inside the water system. At that time, you can check the water pressure gauge. If the pointer vibrate a lot, that indicates too much air inside. Or maybe there's something wrong with the main board. Here is the details. So for the flow switch, to check the wiring and also the connection to the PCB. And for the water system blockage, just focus on the filter, whether this is some blockage or the coil deformation, just like this. And as for the water flow rate, if it is not enough, to check the water pressure to ensure it is in this range. And next is the gas mixing protection of the four-way valve. And first of all, this is only the symptom. There's no error trigger. That means the system will not tell you that I find that there's something wrong with the four-way valve. It just will display the symptom. And before that, I'd like to introduce how the four-way valve operate. And from this picture, you can find it. Here is the slider, this one, and there are 4 ports. D connect to the compressor discharge, S port connected to the compressor suction side, E for the evaporator, C for the condenser. And here there is a pilot valve. Actually, this is the small size 4-way valve. You can also find it, this one, it is the capillary. It connected to here to detect the high pressure, and this into here to get the low pressure. And we just use this small size 4-way valve to conduct the direction change. And here currently it is the heating mode, because the refrigerant from the compressor will flow to the condenser first. So if we need to change it to cooling mode, the system with the 4-way valve will just like this. So you can find that we just move this solenoid valve. Then from here, we just use the inside refrigerant pressure to push this slider to the other side. So for this gas mixing protection, that means this slider will stay at this middle position, right? And then the refrigerant from this deep port can flow into these 3 pipes, and then there's no heating or cooling. And here is the change direction requirements. And first is we need to ensure the solenoid valve, which is this one, it has enough power, which is enough voltage. to push this one. And the next is the smooth movement of the slider, just like this one. For example, if this slider is deformation, also makes the inside this cannot move. And also the next is to ensure the cleanness of the four-way valve. Just for example, this the impurities which is jam or stung the capillary. It will also make the pilot wheel cannot get the high or low pressure. Then if you cannot get the pressure, it cannot move this one. If it cannot move this one, also this slider, it cannot change direction successfully. And here is the checking method, and of course you can just touch the pipe just like this to feel it whether it is hot or cold. If the temperature is close, that means the four-way valve is malfunction. And of course you can also double check from the controller. And the last one is you can also check the pressure suction side temperature. If it is higher than the outdoor ambient temperature, the judgment is yes, it is confirmed gas missing, just like this. And the last, I will play a video for you to how to for this one. You can find that our engineer just check the the temperature difference. You find that this is something wrong. So our measure is just to knock this body, knock this cylinder, to make the inside slider to move direction successfully. Then from the noise, you can also judge that this is okay. You can also confirm from this E and C pi the temperature difference.